Today we're going to be looking at variables in multiple variables and multiple equations. We're specifically doing three variables. So we talked about substitution and elimination yesterday. Now we're going to do it with three variables. So the first one, substitution, is pretty easy. We're going to be writing out an equation based on a theater that charges 75 for section A, 55 for B, 30 for C. So that should be pretty easy. $75 for each seat in A, plus 55 for each seat in B, plus 30 in each seat. And we're told later on that they bring in, if they're sold out, this much money. So if I keep all the money together, it should come out to $870,000. So that's one equation. Also told that the theater holds 23,000 people. Okay, so all three sections added together has to equal 23,000 people. So there's a second equation dealing with how many seats there are. And then we're told that section B has 3 times as many seats as section A. So B equals 3A. Why does B equal 3A and not B times 3? Because if you think about it, if B has 10 seats in it, if A has 10 seats in it, B would have 30 seats in it. So it's the A number of seats times 3 that gives you B. So A times 3 gives me B, based off of this wording. So the first type of solving is pretty simple. It's just substitution. If B equals 3A, then I'm going to put 3A in for each B value. And I do that in the other two equations. So this B gets replaced with 3A. This B also gets replaced with 3A. So what I have then is 75 plus 3 times 55, or a total of 240 A's, and then I carry down the other two numbers. Here I have a total of 4 A's plus C and carry those down. So by substituting it in for B, I've eliminated the variable B. And now I have two equations, and I'm going to bring these down, but I need these to cancel. So when I'm looking at these two equations that I have, I see that this is 30C, this is just C. So I should be able to eliminate the C's if I multiply this equation by negative 30. So I'm going to transfer it down. This one's going to come out just like it is. This one gets multiplied by negative 30. It gives me negative 120, negative 30C, and 23,000 times negative 30. So now the C's cancel. This is just basic elimination. I combine my A's together. 870,000 minus 690,000 is 180,000. And then I divide by 120, and I get 1,500 seats in section A. But I also know that B is 3 times that, so that's simple enough to figure out what B would be, 4,500 or 3 times that. These two together give me 6,000 seats. And if the total number of seats was 23,000, that means section C has 17,000 seats in it, simply by subtracting the 6,000 from 23,000. Now, substitution usually is pretty easy. It gets a little tougher when we try to use elimination. So now we're going to look at number 2 here. And I'm going to show you how to check it on the calculator as well, but we're going to solve it here first. So we're looking at this system of equations. Comes from a very simple word problem. I have 2 pizzas, 1 liter of soda, and a salad. 2 peas, 1 liter soda, 1 salad equals 14. And I do that for each of these 3 sentences. 1 pizza, 2 liters, and 3 salads is 16. 3 small pizzas, 1 liter, 2 salads, 22. So the equation should be pretty easy to write. Each sentence gives us an equation. And now I'm going to use elimination. So what I need to do, it's a 3-step process. I'm going to pick 2 equations and eliminate one of the variables, P, L, or S. I'm going to focus on L. So I'm going to try to eliminate L first. So I'm going to pick the first 2 equations. I'll label them equation 1, 2, and 3. So I'm going to use equation 1 and equation 2. So I have 2P plus L plus S equals 14, and P plus 2L plus 3s equals 16. And the question is, how do I get L to eliminate? Well, I'm going to have to multiply this equation by negative 2. So let's go ahead and rewrite that. I'm going to rewrite that top equation as negative 4p minus 2L minus 2s equals negative 28. The second equation I didn't change, so I'm just going to rewrite it as it is. Now that's why I multiplied by negative 2. If you don't understand elimination from Algebra 1, I multiplied by negative 2 because that would cancel out the L's. Because I already had a 2L here, so I need this to be negative 2L. So I multiplied the whole equation. Make sure you multiply everything, even the 14, by negative 2. So I end up with negative 3p when I combine these together. Negative 4 plus 1. L's cancel. Negative 2s's plus 3 would be 1s. And negative 28 plus 16 is negative 12. Okay, so I have one equation. I'm actually going to go ahead and write that one over here because we're going to be using it in just a moment. Now I'm ready for this equation. For the second equation. And so I'm going to pick two other equations. So I already used equation 1 and equation 2. This time I'm going to use equation 1 and 3, a different combination. So I used this combination, 2p plus L plus s equals 14. And I'm going to do equation 3, but right now the L's don't cancel. And it's crucial that you cancel the same variable you did in step 1. So because I canceled L here, I need to cancel L again. Well, right now these L's don't cancel. But if I multiply this by negative 1 and change all the signs, negative 3, negative L, negative 2s, negative 22. So I just multiplied that whole third equation by negative 1. Now the L's cancel. Okay, so let's combine these. 2p minus 3p is negative p. 1s minus 2s is negative s. 14 minus 22 is negative, oh, hold on, my program's sticking. There it goes, 8. And so now I have my second equation. My second equation is n minus s equals negative 8. Now, oftentimes at this step, you're going to have to multiply by something to get something to eliminate. Like, I could multiply the bottom equation by negative 3 so that the p's would eliminate. But I don't need to do that here because we already have s's canceling without multiplying anything. So when I combine these together, I'll get negative 4p, s's will cancel, negative 20, p equals 5. So that tells me the peaches cost $5. Then I'm going to just back substitute. And it says, we take the two new smaller equations, we just did, solve for two variables. So I need to plug this back in and solve for the other. If negative p, which is 5, minus s equals negative 8, and I add 5 over, that's an s there. If I add this 5 over, it gives me negative 3, and then divide by a negative, tells me that the salads cost $3. Then if I come all the way back and I got to fill this in, it says plug it back in and solve for the last variable. So I got p and s from these two equations. But I got to come back up to one of these equations up here. So I'm just going to pull that first one, 2p plus L plus s equals 14. 2p, so the peaches cost $5, so that's 2 times 5 or 10. I don't know how much soda costs, but I know a salad costs 3. And now I'm going to solve. 10 plus 3 is 13. When you subtract 13 over, 14 minus 13 means that the soda, a liter of soda, costs $1. So now I have the full solution, and I've solved for each missing part. Now you can also check this on the calculator, and I have the steps laid out here. You go to the equation app, you press F1 for simultaneous in that equation app, and then F2 for 3 unknowns. And you can use this to solve a 2 unknowns where there's just 2 variables as well. But we're going to use it for 3 unknowns, F2. And we're going to enter each coefficient. So when I go to enter this in, I'm looking at my original equations, and I have my screenshots here. the first equation is 2p, 1l, 1s14. So I'm just entering in my coefficients. 2, 1, 1, 14. 1 pizza, 1 soda, 3 salads, 15. 3 pizzas, 1 soda, 2 salads, $22. You enter all that into that screen and hit solve, it will give you the answers. So you know exactly what answers you're looking for as you do all that work previous. Okay? All right, pause this and then go back to the live section.